All right, hello, everyone. Can everybody hear me? Just doing a quick mic check, uh, making sure that everything is running smooth. Can you see my screen? You can hear me? Okay, thank you. Thank you for confirming. Awesome, awesome. Okay, just pulling up my presentation screen. All right, everyone. Thank you for joining us. My name is Matthew Daniel. I'm the product manager of the new MV Inverter. We're very excited to introduce this new product line and all the integrations with our Fortress Power batteries. We're going to talk about a couple stuff in this webinar, starting from the products, installation, how to integrate our Fortress Power batteries with these inverters, and how to set up the LCD screen in terms of programming this inverter. And we're going to talk some other features as well of the MV12K, along with the MV8K and 10K. Um, we're really excited. So we like to thank you for your time, for joining us. We're gonna get to it. Okay. Okay. All right. Awesome. So as I said, we're gonna talk about the new products, how to install in terms of cabling, uh, setting up the screen, how to do closed loop communication, what are the steps to take in consideration. It is a very, very simple step. It might be, somewhat overwhelming for, some of the new installers trying our product in terms of, what to do, but I rest assured it is super simple, easy to do, and we do have integration guides set up in our web page. We have, how to set up your monitoring system, how to set up your how to do a firmware update, which is not needed with our MV inverter, but just for future enhancements and bug fixes. We do have all the documentation that is downloadable on fortresspower.com. So let's get things started. So, hosting the new 12K hybrid inverter, the new NV inverter, it has a whole home backup 200 amp pass through, meaning 48 kilowatts of power. Um, there is some way to manage, if you're on a place where you might have grid outages, you can easily install a load manager just to help with that disruption if you're running more than 12 kilowatts. Because at when there is grid outages, your inverter is able to support 12 kilowatts continuously. Okay, and that means also on your AC output in terms of your AC input as well. Okay, so you can sell back to the grid 12 kilowatts continuously. Okay, it does have a built-in rapid shutdown transmitter. It's APS. Okay, but it is compatible with Tigo. We just retrofit the cabling inside of where the APS transmitter is connected, and you can connect your Tigo transmitter, and it will work perfectly as well. It has a max PV input of 21 kilowatts. 21 kilowatts. Out of those 21 kilowatts, it will regulate to 18 kilowatts. Where out of those 18 kilowatts, it can support continuously battery charging up to 12 kilowatts. It could support 12 kilowatts continuously on your AC output and grid selling. Okay, and for the remaining kilowatt, you can use to, let's say you're selling 12 kilowatts continuously, you can use the remaining 6 to charge up your battery all at the same time. Okay, it has its built-in AC and DC breakers. It includes 200 amp load breakers, and it includes two 200 amp battery breakers. Okay, it does have a 250 amp continuous charge and discharge capability, so that's where we include 200 amp breakers. It is IP rated 60 IP65 for indoor and outdoors. We do have the Flex Tower as a solution for outdoor installations. Typically or mostly for those that are using in applications of harsh weather, where you need to keep the system cooled or heated, you are able to do so. Excuse me. Hello? Okay, sorry. I'm sorry. Okay, excuse me. So I've been told that my slides are not changing. Can anybody see this slide? Hello? Yes, now we can. Okay, great. Okay, can you see you can see the 12K, it says 12K hybrid battery inverter. Yeah? Awesome. Thank you guys. Thank you guys. I apologize for the technical difficulties, but we will this is the first slide, so you didn't miss much. So, okay, great. So let's let's resume. Okay. So, yes. So as I was saying, with the Flex Tower, you can use it for those harsh conditions, right? Um, but for normal operating conditions, you can use the MV12K outdoors. Okay, it has IP65 NEMA 4X case on it, and it does provide a color LCD screen to locally program your inverter. Okay, it has a built-in uh, three MPPTs, um, where out of those three MPPTs, you are able to put two strings in the first MPPT and then uh, a single strings into the MPPT 2 and 3. Okay, and then I'll talk about more about the power ratings of those uh, as we progress. You can put 5 units in parallel, although we are working to expand our paralleling capabilities and maybe up to 10 units in parallel as well. It has a built-in generator input up to 90 amps. Okay, so you can hook up your generator input up to 90 amps, and the generator input will also serve as the AC coupling method. Okay, so you can either put a generator in the generator input or the AC coupling input as well, up to 90 amps. And then you include your online monitoring app, which you can download right now in your iOS or Android phone. It's called Envy Fortress Power. Envy Fortress Power. But it does also have local monitoring capabilities by connecting directly into the inverter's dongle. So to take a look inside and on the sides of the inverter, this is the dongle that I was referring to. Wi-Fi dongle hooks up to the side. This is a button included with the inverter. It is not a power button, just in case. I know we've seen that in our in some other inverters, but it is actually a rapid shutdown switch. So you're saving on having to add a rapid shutdown button. Okay, and your PV disconnect. Okay, then we're moving inside of the MV. Moving inside of the MV, we have first the communication board. The communication board will serve to communicate both the inverter with the battery to doing closed loop and inverter to inverter when you're doing paralleling up to 5 units as mentioned. Okay, it also provides a USB port. As we, it is a new product, and as we come up with better applications, better settings, we can actually locally update the LCD by just plugging a USB with some simple step-by-step processes. Takes about 5 minutes to upload the software into the inverter, and then you have some new settings. Then we have the PV input, which will have, in this case, this is the 12K cabinet. Um, this is the first MPPT ports, right? Up to 2 strings in the first MPPT, and then you have your MPPT 2 and 3 for independent strings. So you can have, 8 strings in MPPT 2 and 6 strings in MPPT 3, right? It doesn't have to be the same modules amount. Whereas in MPPT 2, it does work together for both strings, so those will have to be the same. Then you have your DC battery breaker independently with both battery ports for battery ports for up to 2 batteries in parallel connection. More than 3 batteries, then you would have to connect from the battery ports up to a bus bar and then go on to distributing to, the 3 batteries or the number of batteries surpassing 2, right? This is your generator port or your AC coupling port. This is your load port and your grid port, as well as your low breakers, 200 amp breakers, and your neutral bar. And not forget to mention, when hooking up a generator, this inverter actually also can do two wires start the generator through these ports right here. They're normally open, normally closed ports. So we can hook up a 2-wire starter to the push button of the generator and hook it up to these ports right here, and then program your settings. So when you need when battery is in, let's say, a 20% state of charge, which is what we recommend for recharging for our um, 10-year warranty, cycling, depth of discharge. We recommend 20%. So in that set, we set it up to 20% and start the generator automatically. And not to mention, so we are, as we notice here, these are compression lugs. So we would have to use, we use ferrules, right? We crimped it, and then once we crimp those ferrules into the bare copper, for battery cable. Then we hook it up directly into the battery port. Battery cable tends to be has fine strands. So if you were just to hook it up directly into the battery ports, you could actually break some of the fine strands, right? Um, we might actually consider changing into ring terminals. It would be awesome. I don't know how the poll system necessarily works, but it would be great if you can just leave us your comment if you prefer. What do you guys prefer? Lug, uh, ring terminals, or compression. So just let us know. We take a lot into consideration. Again, it is a new product. We take the feedback. But for now, the product as it comes with compression terminals. So moving on, um, as we've stated, this is a inverter that can do a 250 amp capability, right? So if you were to put it with one Evo Max, which has a discharge capability of 250 amps, we would have to bridge these ports, right? And one way to do it is if you have 2 cables going into this double wire, double barrel mechanical lug, and then connect that directly into the Evo Max's battery terminals. That's one way to do it. You know, you can this ports support 1-aught to all the way to 3-aught cable connection. So that could definitely be a possibility to go con when connecting one inverter to one Evo Max. You would use this lug right here. We do recommend when using this that you keep the Evo locked, the wiring cabinet, just for extra safety, extra precaution, um, because these will be energized and exposed inside the cabinet. So just another added safety feature for those installations. So presenting now the 8K, 10K NV inverter, and personally one of my favorites. I happen to be in Puerto Rico, and we see a lot of installations using the 8K inverter just because of the main panels in Puerto Rico is usually an average 100 amps, but it's rightfully so applicable to states like Hawaii, for example, that I believe they use also on average 100 amp main panel. But yes, this is a inverter that can withstand PV voltage 100. The range of PV input, sorry, is 100 volts to 600 volts, same as the 12K, right? But the difference is that the 8K can tolerate up to 13 kilowatts of max input power, and then the 10K can withstand up to 15 kilowatts of power. Out of those, it will self-regulate to 12 kilowatts, and then from those 12 kilowatts, do the same applications of the 12 kilowatt inverter. You can distribute 8 kW to your loads, or 8 kW, exporting to the grid, and the remaining you can use to charge your battery, or just use the full 12 kW capability. I'm sorry, 8 kW to sell to the grid, sorry, and or 8 kW to provide to your loads, or 8 kW to charge up your batteries. Okay. The max MPPT current is 25 amps. It does tolerate, it has two MPPT ports, right? Where you can connect up to 4 strings as well. Each bus is about 15 amps. About yes, about 15 amps. This 8K and 10K can tolerate up to 25 amps per MPPT. Okay, it has a generator port as well, uh, and it can do AC pass through up to 90 amps. Okay, 90 amps, as well as the AC coupling capability as the same as the 12K. And with the battery, it has a max charging and discharge current capability of 167 amps for the 8K, and then 210 amps for the 10K. Just checking. You guys can see, just quality checking real quick. You guys can see my screen, right? We're talking about now the MV distribution panel. Great. Awesome. Awesome. Okay, so for the MV distribution panel, this is a box that we designed for the 8K and 10K. It comes with all of the AC and DC breakers that you would need to make this connection, right? Comes with a 250 amp battery breaker, and three AC breakers of 63 amps, one for generator, one for the AC input, and one for the AC amp output, as well as uh, as well as a, a breaker, a bypass breaker, as displayed as such. This is the bypass breaker. These cable connections are made, come already with the MV distribution panel to make that bypass feature. This is where you would connect all your AC input and output, uh, AC input coming in, and then going into the the ports of the MV8K and 10K, and then load coming out, going into the power blocks here, right? It can tolerate up to 2 battery connections, as we see here, also using compression terminals. And it does have a little DIN reel, so you can put your fuse breakers to disconnect PV as well. It is IP65, which is suitable for outdoors. And it's actually the solution that we have for there's a major government project in Puerto Rico using this 8K with this MB distribution panel. They're all working outside, either in the north, west, or east orientation, since they are both, IP65 NEMA 4X. We do not recommend, however, install it in the south side, just because that's where you really receive direct sun. And it's not that our inverter cannot manage it, it's just that you have an electronic device such as the LCD, and that constant sun exposure, could, damage it in the future. So we can install these outside, but just not have it in the south side. So moving on, here you have a more detailed description of how to connect those PVs, right? In the case of the 8K, you have, one string going into MPPT 1, and then another string going into MPPT 2. Just a brief example. Whereas in the 12K, right? I think I see somebody asking one of the questions as to what the voltage rating is. The voltage for both 8K, 10K, and 12K PV input is 100. Maximum is 600. Now we do have like a maximum recommended, let's put it that way, of 550 volts, right? So on the 12K, the first MPPT can withstand up to 25 amps, okay? And then the second and the third MPPT can withstand up to 15 amps, okay? We would use cable 10-8 for this installation. And moving on, the grid connection for the inverter. So as we've talked, as we spoke, I showed you where the grid connections would be, and then the CTs that will go from grid to inverter, assuming whole home backup solution. That means that you have the meter, in between the meter and the main panel, you have the inverter, right? That's how you would do a whole home backup solution. Now, if you're doing a partial backup, the CTs would go in between the grid and the main panel, okay? And that is if for some reason, the customers wants to do fast zero export, it would take the consumption and provide power to that consumption, right? It's called fast zero export. Basically, I don't want to export to the grid. I just want to provide the necessary power for my loads. Okay, great. So these CTs will measure the power consumption and will allow the system to provide that necessary power without exporting anything. So when installing the CT in the designated CT port, what you would do is go to the screen, right? Go to the LCD screen and set up your meter functionality, right? Your set meter or no, I'm sorry, meter or CT. You would select CT, and the meter type will be 0-1 phase, and then the CT ratio will be 1 to 3,000, assuming 120, 240 split phase solutions, right? We are working, systems will be available for 3-phase around, I would say, beginning of June. So we will have that 3-phase applications for these inverters as well, in which case this 0-1 phase would change. I see that we have a couple questions. If I am not able to answer at the end of the presentation, be happy to send you an email So just go ahead and submit any of your questions or any doubts that you might have, and I'll be happy to answer. Awesome. Okay. Make sure that when you're installing the CTs, the arrow is pointing into the direction that's going into the inverter, right? So if I am looking at this arrow right here, this side would be grid and this side would be the PCS or power conversion system, which would be your inverter, right? Make sure that when it says CT1, it goes on line 1, CT2, line 2. And then, once we connected everything, all the electrical connections on the ports, now we're beginning to basically wire the system so we can make closed loop communications either with our eFlex or with our Evo Max, right? So in the case of the eFlex, starting with the commissioning sequence, um, the MV inverter, let me stipulate this, right? The MV inverter is a new product, right? And as simple as it is very simple as a plug and play. You don't need to do any cable modifications. It's just connecting the cables that come with your battery directly into um, the designated communication port, as right here in the 8K or 10K. However, you might get a battery that had an earlier production um, that was not yet compatible with the MV inverter, right? Our newer production will come already with the firmware that is applicable to make these communications with MV inverter. But if you do happen to get it, you might get a battery that might still have an earlier version. In which case, if you have a CAN tool, which is a tool that we provide at tech support, um, that allows you to update the firmware uh, to update your systems to have the latest version on, let's say, the eFlex 3312 or 4006, right? If you do not have that tool, go ahead and create a support ticket on fortresspower.com/support, and we will send you a CAN tool free of charge. Okay, so as you notice, both eFlex and Evo Max have different revisions, and this is just a disclaimer that this was due to the demand that we had to kind of supply when COVID hit, right? There was a semiconductor shortage, and we had to find ways to mitigate the situation by using other semiconductor providers. It didn't affect the quality at all. It's just that we had to use new hardware, right? And so you will see the earlier version would have Rev A, for instance, and the later version would have Rev D, and which means that, let's say you have 3 flexes and you have 2 that have Rev A solutions and then 1 that is Rev D. All you have to do is pull your CAN tool, um, and just we provide the firmware files, so you would just update them with respective firmware files. If it starts with 3, you will give it the firmware update that starts with 3. If it's if the version is 4, then you would give it the firmware version that starts with 4. Very simple, very straightforward. Okay, and same with the Evo Max. Uh, the only difference here would be that one, has the STO version that is Rev A, and one has the GD version that's Rev D. So what I'm trying to say is when updating the firmwares, we would update it with the respective version according to what shows up on the software, right? So that said, to communicate various batteries, if you have various batteries, for instance, you have the Evo Max, you have 3, right? The Evo Max has a touch LCD where you can program what the battery ID is. So let's say you choose this as the master, right? So if this is the master, then this would be battery 1, this would be battery 2, and this would be battery 3. Okay, the protocol is always going to be one. Protocol means the communication protocol that you would use between our EvilMax and the MV inverter. Okay, um, so once that's set on the LCD screen, then we move forward into terminating the communication, right? We put a communication cable that's included with the battery. Communication cable from the COM parallel ports is going to go from out to in, and then you terminate the communication with the 120 ohm dip switch that's integrated into the EvilMax cabinet. Okay, and from there you take the existing wire cable that comes with the EvilMax. Is usually an RS485 cable that we used to use for communication with Solarc. You can go ahead and use the same cable, put it on the RS485 port of the EvilMax, and go ahead and put it on the battery communication port of the MB. Same thing with the eFlex. The eFlex does not have the switches that the EvilMax has. What it has instead is a little, I what do you call this? Ethernet head, let's put it that way, or bud that you would connect into the last battery, right? And it's very important that you use these because these have a 120 ohm resistor already in it. All right, so it's just to terminate communication between battery to battery. You connect that into the last battery, assuming this is the last battery, right? You screw it in, then you connect the communication cable from battery to battery that's included also with your battery packaging. And then you're going to take the battery cable, that's the leftover battery cable, and you're going to connect it to this pinout converter. This pinout converter, what really is also another terminator to terminate the communication between battery to battery. But as you see, it's also a female coupling. So internally, it has a 120 ohm resistor that's going to terminate the communication, and then it's going to let through CAN communication and RS485. Out of both of those, it's going to go directly into the RS485 battery CAN port. Okay, so very important to use the equipment that we as a manufacturer provide you, not just use like another female to female coupling. You use these exact things. So if you're paralleling multiple inverters, then you would go on the inverter communication board, and how to communicate them would be uh, inverter cable going into from the first communication board up to the second board of the inverter on these paralleling ports. The same goes to the second to the third and the third to the fourth. And then to secure the communication with better quality, we also connect a communication cable that goes from the first board all the way to your last board. Now we do provide some Ethernet jacks or Ethernet ports. So all you would have to really provide is communication cable, and then you can kind of crimp it on site and 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 make that connection. Also, to terminate the communication, similar to how we terminate it into our battery, onto our EvilMax, we have these dip switches that are going to be terminated in the first inverter and are going to be terminated into your last inverter. The remaining in between inverters will remain in a zero position. Okay. And once you do that, all you do is go on the LCD screen. You're going to go on the settings of the inverter. You're going to go on advanced, and then you're going to scroll down and then assign the role to what inverter. So this inverter, as we stipulated it, maybe, let me see. We stipulated here, you're going to assign master to the first inverter. So that and the first inverter is always going to be, or the master inverter is always going to be the inverter that communicates directly to the batteries. So we're going to assign master, right, uh, to the first inverter, and then the rest will be assigned as slave. And one of the very, very awesome things, I mean, before us releasing this, inverters, um, you know, I happened to luckily work at the application engineering department of Fortress Power, and I've seen a lot of these communications with our batteries with other inverters, and I can just tell you right now, the communication with our batteries with the inverter is flawless. We've been testing this about the communication about 6 months prior to launching it, and so far we've had zero errors or zero issues with with the communication using our battery and inverter. So, and it works to perfection. So that said, once you paralleled everything, if you wanted to see it, if once you parallel everything on the LCD, if you were going on the web portal, right, to conclude that paralleling, which is not necessary, but if you want to see the inverter as a cluster, right, like if you have multiple inverters and you want to see it as a cluster rather than, one inverter, then all you do is register the serial numbers per inverter, and then you're going to click on parallel. And once you click parallel, you click on the paralleling group. In this case, it's parallel A. The parallel index would always be the number of inverters, and then the parallel number model will be parallel. And once you do that, you will see on your web portal a cluster, and on your app as well, you will see a cluster rather than a single inverter. Okay, this is just for app and web portal reference, right? So, but this is the web portal interface of what you would see in your home screen, for instance. All right, you see your PV production, your battery charge and discharge, how much you've exported, and the flow of energy throughout the entire system. So now we talked about how to connect all the electrical cables, how to do closed loop connections, and now we're going to talk about the LCD interface, how to program the inverter. So once you boot up your inverter, which is usually what we use on our manual and our guide in your commissioning sequence, right? Going back, let's say, let me go back. Commissioning sequence. When you commission your system, right, we're gonna start commissioning with our battery energy. Okay, so in the case of the eFlex, you're gonna start turning on the master battery. So that would be this guy right here. You're gonna press it, leave it for 3 seconds, press the second one, leave it for 3 seconds, and then press the fourth one and leave it for 3 seconds. Once your system boots up, right, assuming that your battery breakers are also on, then we begin to commission the system. You will start always with the DC, turning on with your battery, then your PV. Once we set everything on the LCD, we're gonna always recommend putting the system in standby before proceeding, right? And then I'm gonna go ahead and explain what else, what the remaining steps are. But let's start with the home screen of the inverter, right? You see the power flow, and then you're gonna notice here the number, right? The product number or the inverter number is gonna be 1, right? And then it's gonna say roll, and it's gonna say M for master, and then what phase is it, right? So here we can see that, it seems almost like a fast zero export application, since there's PV production going into the loads, the battery is 100% charged, So, and then it's not exporting to the grid. So it seems like a fast zero export um, application, right? So here you have your grid frequency and voltage and power. Here you have your load consumption. When the backup is not used, it will say standby. But when your backup is used, this flow is gonna redirect itself to this icon right here. And then you have your battery, which will depict what the battery power is going into it, your state of charge, and your voltage. And then we have what we call PV1, PV2, and PV3 on your PV production. It's just another name for MPPT1, MPPT2, and MPPT3. Okay, as well as what the voltage of that PV input is and what is the power production. So initially, when booting up the system using batteries, you might get a warning indicator, but that just means, by default, you will see the inverter that is trying to search for grid, right? And your grid is not enabled yet because we're doing the first initial phase of commissioning. So you might get a warning, and that warning might say, trip by AC or AC abnormal. It's perfectly normal. It just means that it's not recognizing AC. Okay. Then you will see your PV energy, the what you've produced daily, and then total charge energy for your batteries, daily and total, as well as same thing for export and consumption. So real quickly on the settings, if you go on settings, right, we were in the home screen, now we're in settings. If you click on, wait, what happened? Okay, click on device info. It will, here you set the time, real time or wherever you're located. The backlit timer, just for energy saving, it's maximum you can set it is for 90 seconds. The model, this will come already pre-configured. It will tell you the number of the model, the serial number, firmware version, build version, LCD version, image version, and icon version. Okay, it's pretty standard. Next, you have a little line of defense. Let's put it that way. You might be setting your system, and the system is not doing what you might think it should be doing. So it has a little debug feature, right? That you can select the question why there's no power flow out from the grid terminals. It could just, when you click it, it will tell you, listen, for, places that have really bad voltage, or voltage is out of range, or the frequency is out of range. It will tell you that solution, or that answer is like, it will give you a list of possibilities of why there's no power flowing out from your grid terminals, and saying as to why doesn't the battery discharge, why doesn't the battery charge, or why is there no output from the EPS terminals. The EPS meaning emergency power supply, or your backup. So it's pretty cool. So if you're running into a question or some doubts, go ahead and click on the debug feature. It will help you troubleshoot. And if you cannot find a solution, just feel free to give us a call at tech support as well. So going into the data section, here you will see the solar readings. You will see the solar readings, how much voltage is producing on each MPPT, power production throughout the day, as mentioned in the first home screen, right? Now this one is really good because it not only will tell you the battery characteristics and the battery readings from the BMS, right? These are the battery section, but it will also tell you if you properly commissioned the batteries. So our recommended charge, for instance, for the eFlex is 50 watts, or 50, no, sorry, 50 amps DC. So if you have 3 eFlexes, you should have a reading of 150 amps on the iMax charge, right? And that's how you know that everything is commissioned properly. Now, if you have an Evil Max, it should be about 180. So if you have two Evil Maxes, this should be 360, and so on and so forth. Okay. It will also tell you the average cell voltage of all the batteries, the average temperature, and so on and so on. Now, if you integrate a Guardian, which is another line of product that we have, into the batteries, you'll be able to monitor the batteries um, in a more detailed, not just monitoring a battery bank, but monitoring your batteries individually. And on top of that, also you will be able to remotely update the battery firmware. So I truly recommend the Guardian. Um, the Guardian does not stop at innovating in terms of battery monitoring, but it will also serve in the future to integrate battery with inverter. Okay. So it'll be like a one-stop shop to programming everything. uh, Grid and UPS, basically, this it's the same line. In terms of telling you the electric characteristics, what voltage is on each line, frequency, how much you've, imported or exported, and then UPS, how much of power did you use during backup, what was the voltage per line, etc. And you can also see all these values remotely through our Envy web portal or app as well. So here, the alarm section, if you happen to run with a fault, it will light up red, as well as the inverter's LEDs next to the LCD. It will light up red. So if for whatever reason this happens, don't hesitate to give us a call, and we can help you troubleshoot. Okay. Same with alarm. Um, One of the things that we've gotten a lot is that, let's say you have battery open, right? It could be something simple as, the inverter is recognizing the battery, but you just haven't turned on the battery breakers. So that's what battery open would mean. Or let's see, let's see. Trip by no AC. When you're commissioning the inverter using our battery, you might see this first warning say trip by no AC. It means, you have no grid going in. So just a couple things that it could be, no biggie. But if you are stuck, again, don't hesitate to give us a call. And then it will store all of these um, error codes into the inverter, as well as the alarm codes. So now you have, everything that's about data, how to read it, and now we're going to program the inverter, right? So on the basic settings, right, we're going settings, and then we're going basic. When you enable standby, you will put the system in complete standby, where there will be no PV production or um, load output from your batteries. However, it will still do AC pass-through. And that's a really, really, really good feature, because when we do firmware updates, let's say remotely or locally, we always recommend putting the system in standby, and then the homeowner might not even know that their system is being uh, updated. So for grid tie users, this standby feature is phenomenal. Installers can do this remotely. You can ask us to do it for you, no biggie. Also, we put the system in standby when we're doing this initial commissioning, right? When we're programming the settings, changing frequency, changing grid regulation, you should always put it in standby. Otherwise, the settings will not change when you're setting the grid regulations. This is to restart the inverter in case, the let's say you've corrected any or troubleshooted the warnings. You can just restart the inverter and it will clear up the warning or fault alarm. Okay, when enabling the export grid, this is basically the feature that will allow you to export to the grid, and then you can control how much you want to export here. Okay, if you want to do fast zero export, you just select here and then disable export to grid. And to make these changes, it might ask you for code, right? It's very simple. It's just 5 zeros to apply that code. Make sure that every change that you do, you click on set. Otherwise, it will not save the configurations. So this is a vivid example of a system being in AC pass-through when system is in standby, right? There is no battery output. It says 0.3 volts, but I'm pretty sure this was at night. But if there was any voltage or on the PV, it would not supply. So this is a grid tied application when system is exporting, right? Supplying to the loads at the same time. It's supplying to your exporting to the grid. And here you have zero net export. You can see that batteries are charged to 98%. We have grid available, but we're just not exporting. So moving on to the charge settings, everything that you do from now on using our batteries will be used using SOC, right? You don't need to use battery voltage. You don't need to set float, absorption, or bulk voltage, which are like the phases of charging. You don't need to set any of those. You just use SOC, and everything you do from now on is based on SOC. So here we stipulate the recommended battery current charge current limit. If we have 3 E-flexes, then you put 150. If you have 1 Evo Max, then you stipulate 180, right? Obviously, this goes from 167 on the 8K, it goes to 210 on the 10K, and it goes to 250 on the 12K. Okay. If you wanted to enable AC charge, you can do so. And then you would use time of use settings for those applications, and then you can decide at what SOC you want to stop the AC charge as well, and also limit the AC charge power. Now, keep going on the charge settings. If you have you're setting up the system, and by default the MV inverter will prioritize in this sequence. It will prioritize your loads. Any remaining or existing will go to your batteries, and every remaining or existing will go to your exporting if you're having the export feature. Or but if you enable the charge first PV option, then your inverter is going to prioritize your battery first and then your loads. And if you can export, then you will export as well, unless you disable it on the basic screen, right? So, and you will also habilitate that by your time of use settings. Okay, you stipulate the charge first power, and then stipulate when you want to stop based on SOC settings. Now, we are compatible with lead acid batteries. So if you, for those of you who still like lead acid technology, I'm not sure whether to migrate to lithium batteries. We got you. We understand. And we we have features that support lead acid. Okay, where here you would stipulate the absorbed voltage, flow voltage, and then the start of the rate voltage. So here is the function as by default, what the MV will do by default. Okay, so it's supplying the loads, then it's supplying power to the batteries, and then it's exporting the remaining, right? All at the same time. Now, if I change it to battery, it will it will to battery low and grid, then it will provide battery first. The remaining will go to your consumption, right? And as we can see, the production is not enough to supply what this consumption is, so it's being, the remaining is coming from the grid to support it. And moving on in the same generator functionalities, um, we here stipulate the charge current limit of the generator and the generator rated power. Now we do recommend, let's say, if you have a generator with a set power rating, just subtract 10 percent of what that power rating could be, just to avoid any potential throttling, right? You don't want to max out your generator's power capability, and this could result in throttling. So just use the 90%, or you can use the 90% of the generator's capability, right? You can stipulate the generator to start based on SOC, as I said, or end as on SOC. The same with voltage for open loop or lead acid battery applications. At the same time, here you would set the AC coupling function that will enable the AC coupling uh, application to charge the battery at stipulated start SOC and end it on stipulated end SOC. Here we have a AC coupling application. This installer at the time was actually charging his electric vehicle. So he just had around 2 to 3 kilowatts of AC coupling power at the moment, and then discharging 9.7 kilowatts, and then going 11.9 kilowatts of continuous power to the load. So there you have it, 12 kilowatts of continuous power discharging to an electric vehicle. Pretty awesome. On the discharge section, the same thing pretty much as the AC, you set it to SOC, discharge current limit. Here you would use our recommended discharge settings based on our data sheet. And then you have your on-grid end of discharge. Basically, you can set these or regulate these to go from 90% all the way to almost 5%, based on your on-grid end of discharge. So that would mean that when the battery reaches a certain state of charge, the grid will kick in to provide the existing loads. Same with your off-grid for off-grid scenarios. Okay. On your, yeah, so off-grid here. So if you have, let's say, off-grid and you have a generator, we recommend setting this maybe 5 to 10% lower than your generator settings, so they don't interlatch, right, or intermingle. Sorry. And then while enabling the forced discharge, and using time of use settings, it will force discharge the battery into selling to the grid. And you can limit the power by using the discharge power function and then stopping at the desired SOC. Now we have the grid peak shaving. right? To offset, some of that power and help with demand response. You enable it and set your time of use, and then enable how much power you want to shave out of that, out of AC, right? um, Here with smart load when enabled allows for the generator port to become actually an output. So by enabling smart load functionality, you can hook up on, it's basically like a smart load management, but instead of being, 6 or 8, it's one, right? Um, but it has that capability. Um, so it will enable itself when two conditions are met. So when the battery is at a certain state of charge that we stipulate here, and that the PV power surpasses the power stipulated here as well. Otherwise, you can set it to on grid always, and it will provide, the load will be provided by the grid. So this could be cool for like a pool pump or even your EV charger, etc. So now we're going to advance. Advance, we stipulate here how many PV inputs we're using, or how many MPPTs, sorry. You can select all three working independently. You can select the first one, PV only MPPT1, MPPT1 when 2, etc. Right? Here we set the CTs as we mentioned before. And then here we enable off-grid output. So the inverter does go in backup mode. Seamless switch when the inverter transitions from from has that grid outage, it will switch to 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 backup in less than 20 milliseconds. Okay. Here we have CT direction reverse, which is a really cool feature where let's say you install the CTs with the wrong direction. You can just enable this and save you a trip back to the installation site, let's say, and it will, correct the orientation in the reading. So it's pretty awesome. Charge last. That would mean if you enable this, you would support your loads first, then your grid export, and then you would provide power to your batteries. When enabling rapid shutdown disable, you basically enable this when you're using systems with AC coupling, where the microinverters itself have their own RSD functionality, right? So you would need that here. um, AC coupling, when enabling AC coupling here, this is how you would enable it. And then, as talked about before, in the charge and discharge, or the charge setting, is where you would program it to work when desired. And then EPS output without battery. One of the cool things about this inverter for both the 8K, 10K, and 12K is that your inverter could actually supply the loads completely with using PV. You don't need battery or grid, which is pretty awesome. Um, Obviously, the Achilles heel of all this is the sun. So if you have shade or you have rain, you might not meet the consumption. But it is a pretty cool feature to have, especially for emergency moments. Your battery drained. Maybe you're using lead acid batteries. You don't need to um, do anything other than enable APS output without battery, and it will charge your batteries. Um, Here you would enable the smart load, and then if you were running the system with off grid, you would just enable it here, enable run without grid feature, and just enable it here. This is, oops, sorry, I had a video that kind of got mixed up. Sorry about that, guys. Basically, that was a function with off grid. Let me see. Yeah. So this is off grid. Going off grid, you're supplying your loads and then charging your battery with no AC present. Moving on into the advanced section, here you would set the grid type. Which grid type, 120 to 40, 120 to 08. Here you would set the frequency. We actually can do 60 hertz and then 50 hertz as well. And then here you would set the grid regulation, right? Right now we use, you can use US or US Rule 21, UOIEEE, Luma, HECO, Luma for Puerto Rico, HECO for Hawaii. And it will generate the voltage readings according to those regions. And so here we select battery type. You can run your inverter with no battery, right? You can just you can use it with no battery, just grid and PV production, or just PV production as well. So here you would select battery in order to commission with closed loop communication with our batteries, right? Battery lithium, select lithium, and then on lithium brand, we would select lithium zero, okay? We don't need to stipulate any capacity because that is a reading that will come straight from the BMS. So lead capacity would be if you're using lead acid battery type. And then last but not least, here's the paralleling system on the advanced section where you would designate the role of the inverter, whether that's master, slave, and what phase is it. Actually, it has a cool feature where it says how to detect phase, where if you have three phase, it will automatically, and assuming connected properly, you would just click on the reset button and it will designate the correct phase per inverter to each inverter. So here is the system as you can view it with being paralleled, where you can read the cluster. You have three inverters with their frequency and power being generated. So that finalizes the programming. Pretty simple, pretty easy to manage. It might take you maybe 20 minutes the first time, but I can assure you once you feel comfortable with it, it'll probably take you less than 10 minutes to program the LCD screen. So in the local monitoring, the inverter also includes local and remote monitoring. When you download the app, you can sign in with your installer credentials, which we provide for you. So one of the things that we would like is just send us email, stipulating your company name, your name, email address, phone number, what would you like your credentials to be, username, password, and we also stipulate you a code name or an installer code. With that installer code, every time you use it when you're registering the system, it will be the code that will assign that station or that plant directly into your installer profile so you can see it, right? So anyways, you would go to the MV portal on mv.fortresspower.io, mv.fortresspower.io to access the web portal, or download the app on the Android Play Store and the Apple iOS, and just select MV Fortress Power and download it. And this is basically what you would see. Okay. With this system, you can select, it has a fleet view and batch settings. Basically, for these settings that, let's say you have multiple installations with the same configuration, you have you have 4 sites or 5 sites with 3 E-flexes and 1 MV inverter, for example. With the batch settings, you can just select all those systems and then make your programming, if they're assuming they're connected to the internet or to the internet, and you can just configure all of them at the same time. I want them all to be, fast zero export, using these time of use, charge first PV. I can just with one push of a button select all of them, and they will have the same configuration, saving you a lot of time and costs, which is, one of the things that we actually use for a government project that's going is all these installations have the same thing. It's 1 MV8K with 2 E-flexes, and it's all the same configuration provided by the government. And I can just, or the installer with that has all the installations can just press the button and all of them will be programmed the same way. So this is what you would see in the MV app. You'd see your solar production, your battery charge and discharge energy throughout the day, uh, your exporting amount, and your consumption amount, and then your energy flow. Okay, here, that is the overview. When you select data, it will give you these readings. So you can view it in a more detailed scale, when selecting time ranges, monitor, um, and set. Okay, you can actually set all of your settings with your app, um, without the need of, the LCD or the web portal. It's just another option, but you can do it remotely as well. And it gives you the device serial number to which you're doing that. Here is a kind of like a utility compliance report that some jurisdictions do mandate, and we do facilitate that through our web portal. All you have to do is go on the web portal with your installer credentials, and this is basically like your main sections, right? You have monitor, data, configuration, overview, and maintain or maintenance. You select maintenance, you select the UL compliance, you select the station, you press read to read all the configurations that you've installed, right, when you program the inverter, and it will read the grid voltage and frequencies according to that region. And then you put the customer or the end user's name here, and then your utility account, right? And then you press export PDF, and it will actually generate a compliance report, right? So for instance, this was a compliance report for a utility company called Luma. Generated the inverter serial number, the name, which in this case is my name. This is just a test, right? And then the account number with everything ready to submit for that utility company. And then to integrate the Wi-Fi dongle connection setup, to integrate it to connect it remotely, so you are able to view your system connected to the internet. You connect the dongle, right, when the system is energized. Then you're gonna go on your Wi-Fi settings, on your phone, not on the app, just the Wi-Fi settings on your phone, and you're gonna select the dongle. It usually begins with the letter BA in capital letter, and then the serial number. Okay. Then you're gonna go to the app, and then the main screen, which is this. This is the login credentials, right, for the installer. But we're gonna go on the Wi-Fi module connect before logging into anything. Then that's gonna prompt you to this screen, and where you select the end user's router, SSID, right? You select the router and then the router's password. And then before clicking on Home Wi-Fi Connect, you're going to select that the server is North America, right? For North America country, right? And then set, okay? And once you click on set, then you go on Home Wi-Fi Connect. And then you will get a message saying setup is successful, dongle will restart. And that takes about 1 minute. And once you know that you did it successfully, you will see these three LEDs solid green. You've already connected the inverter online, and now you can go ahead and add the station to your to 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 your monitoring system. There's a couple steps towards that. We do have documentation. They're very simple, very straightforward. So, warranty submission. When you go on the MV web portal or the MV app, and when you click on product warranty, it will redirect you to the warranty sign up page where you will basically list the end user's information, um, the installer information, and then what the product that you are installing, right? We like to view all installations, and we try to showcase our installers installations. So in this side where it asks you, put a one line diagram, um, or site pictures, we're more than, we're more than happy to showcase your installations, especially for webinars like these. So go ahead and just, uh, take a picture, give us a one-line diagram, and if there's anything that you might need in the future, we can look at that one-line diagram, right, to help you to assist you in any way we can. Um, and that said, the minimum sizing battery to inverter is, if you're using, you can use 1 evo max minimum for the 8K, 10K, and 12K. If using the eFlex with an 8K, you will need two. Same with a 10K. But if you're using with a 12K, you will need three. Okay. So that will be all for this presentation. It was an honor giving this presentation to you. I'm very excited to keep viewing installations going on with our product. If you have any questions, please don't hesitate to give us a call, send an email. Like I said, remember to send your credentials as installer. You can send it to the sales team or at tech support, and we can enlist you in the MV portal. So whenever you're on site, you're all set to go and you have everything you need. Let me see if I can have access to the questions. Uh, da, da, da. Hmm. Hmm. Don't, but go ahead and trying to expand. All right, just go ahead and submit your questions. We will be happy to um, answer these through email. Say, what battery makes models can your CAN work support with? Okay, Joseph. Um, Joseph, for now, what we're supporting is MV products, MV battery products, and I'm sorry, Fortress Power batteries and lead acid. At the meantime, we do not support any other communication. That is a conversation we're having, hopefully for hopefully something in the future, but for now, that would not be the case. It would just be Fortress Power products. There are NAPSET credits for this seminar. I don't think there are NAPSET credits for this seminar, Michael. But we are looking to integrate um, some of our courses. We're scheduling more. Let's see. twice a week webinars and trainings that eventually that we will give credits to Napset. Video and sound great, thank you guys. I can send this PowerPoint if you guys need it. Yep. How much is MPPT? MPPT is 12K will be 25 amps on the first MPPT. Second MPPT will be 15. Third MPPT would be 15 amps. All of them with a minimum of 100 volts PV and then 600 volts maximum PV. Max recommended 550 volts. It's what we say in, sorry guys, about my English stuttering. Which system, which require with, let's see. Let me see. One more question. Looking at the questions. All right. Retail pricing. Retail pricing, just go ahead and reach to sales at fortresspower.com and they will be able to give you a list of our pricing. Give you what distributor is nearest to you. And then we can go from there. Okay, what is the difference between a solar 12K and a solar and our NV? Good question. So the solar 12K, when you are in off-grid scenarios, it would only support 9.6 kilowatts from your battery, whereas our 12K would actually support 12K continuous. Okay. There are some other minor differences, but the major difference would be that for sure. Mm, mm, uh, who can I contact for sales for Dominican Republic? Um, I believe for Dominican Republic, you can contact, there's a distributor called Equilelectric, um, that where you could find some of these products, Randor. Who sells them in PR? Great question. There are distributors that is, we have Warren Electric, Wholesale, Caribbean Energy, at the top of my list. So yeah. What is retail pricing? I think that's it, guys. I will get back to some of these other questions, but thank you again for joining us. And we're here at Fortress Power. Again, new 12K Envy. We're very happy. Go get it at your local distributors. Have a great day, guys.